All right. Hello, everybody. Welcome to the VCCA's 2021 webinar, Changing Climate series. My name is Dayla Tyler. We're very excited that you're all here with us today, and we're equally as excited that Dr. Grundstein is here to speak on heat and sports safety. I just want to make sure that all of you guys know that all participants are in listen-only mode. You can ask your questions down in the Q&A feature of Zoom, and we will take questions at the very end. And as far as your CME credits, we'll make sure that an email goes out to you guys tomorrow with instructions on how to follow up on that and make sure you can get those CME credits. I would like to hand over the webinar to Dr. Rebecca Phillips-Bourne so she can speak a little bit on our presenter today. Thank you.
Thank you so much, Jayla, and for kicking us off here. I'm Becca Phillips-Bourne. I'm one of the steering committee's members for Georgia Clinicians for Climate Action. And I want to start by thanking my Virginia colleagues for bringing this important topic to the forefront and convening us all today. As a primary care pediatrician here in Georgia, when our kids went back to school, a lot of them this week on Monday or Tuesday, I know that this is an incredibly relevant and timely topic, especially as we've had children who've not participated in sports for a year and a half because of the pandemic and are a little bit on the deconditioned side. So this is important, it's now, and it's my pleasure to introduce Dr. Andy Grundstein today to teach us a little bit more about what we need to know and what we can do. Dr. Grundstein is a professor down here in Georgia at the University of Georgia in the Department of Geography. He's a geographer climatologist with interests on the impact of weather and climate change on human health, with particular focus on assessing and monitoring heat. He's published over 70 peer-reviewed articles in scientific journals, and his research on heat and health has been supported by grants from agencies such as the National Science Foundation, National Institutes of Health, National Oceanic and Atmospheric Administration, and the CDC. He served on various heat safety, medical and science advisory committees, including for the International Olympic Committee, also timely, Inter-Association of Athletic Federations, and the Korey Stringer Institute. Dr. Grundstein received his bachelor's degree from University of California at Los Angeles and his master's and doctorate degrees from the University of Delaware. Thank you for joining us today.
Thank you for having me. Let's see here. Okay, hopefully. Can everyone see this okay?
Yep.
Looks great.
Okay, good. Just want to make sure. Okay. All right. Well, thank you for the nice introduction. And I'm going to talk today about climate change, heat, and sports safety. And my non-disclosure statement, I don't have any financial or other conflicts with my presentation. So let me give you a little bit of an outline about what I'll talk about today. Just my camera here. I'm going to talk a little bit about what I'm calling the climate crisis, a little background on that, and then focus more on heat and sports safety. I'll talk about some best practices for heat safety. I'll share some of the evidence-based guidelines that we established in Georgia and many other states across the country are beginning to adopt, at least for their high schools. I'll talk a little bit about climate data and planning for heat and some of my experiences with the Olympics and other sporting events. And then conclude with talking about hazards, vulnerability, and how do we plan ahead and look towards our changing climate and how we manage that. So let me just start off with some surveys that were conducted to give you a perspective of where we're at. The Yale program on climate change communication has some really nice resources, and they polled people on their opinions and beliefs about climate change in 2020. And the two things that really stood out for me is global warming is caused mostly by human activities. 57% thought that was true. And the second thing is that most scientists think global warming is happening, 55%. So we have some work cut out here. If at the bottom here, I took a statement, let me move my bar here so I can read this to you. We have a statement from the IPCC that was published about 14 years ago, which clearly states that most of the observed increase in global average temperature since the mid-20th century has been caused by people. As a climate scientist, I can say there's not a lot of debate among my field that this is being caused by people and that global warming, or what I call more broadly climate change, is happening. The other thing was they polled people on risk perceptions. And if you look at some of the ones I have kind of highlighted here, global warming will harm plants and animals. Most people think that's true, 71%. It will harm future generations, again, 71%. It will harm people in developing countries, 65%. It will harm people in the US, 61%. But what I thought was kind of interesting was, will global warming harm me personally? Only 43%. So they see this as a severe threat, but they don't see it harming them. And this got me thinking about one of the health communication models, the health belief model that many people use, that one of the things is you need a sense of personal threat for you to actually do something. So I feel like, again, we have some more work we need to do to educate people that this is something that's going to affect all of us. And hopefully in my presentation, I'll share some examples that have happened this summer, how this is directly affecting us. So let me start with a little bit of background on weather versus climate, because at least when I teach my class, there's often confusion about this, and then talk a little background about global warming or climate change, and then we'll get more specifically into the sports. So a lot of people get this idea of weather versus climate confused. And a psychologist friend of mine used a really nice analogy I like to use in my classes, and I'll share with you here today. Weather's like your mood, which can vary from the morning. You can be grumpy and then you can feel good in the afternoon, or vice versa. And climate's your personality, which tends to stay more consistent. And the analogy here is that weather's extremely variable. In Georgia yesterday, we had a beautiful day. It was relatively cool for this time of year and dry. It's going to get more hot and humid again. So it varies a lot. Climate's more consistent. So climate would be in Georgia, you would expect it hot and humid in the summer, cooler in the winter. So then when we talk about climate change, what do we mean? And I should say, I like the word, and most people in my field like the word climate change because it's more comprehensive than just using global warming, because we're seeing changes in other things like precipitation. Climate, you could think of, one of the ways we think about it is statistical properties of things like temperature. So you could look at the average temperature, or the average high temperature, or the total amount of precipitation. So climate change is a statistical change in some of these variables. And there's a few different ways that we can, I guess, think about this or view it. If you look at the figure here, I have on the right here, you have a bell curve, and that peak is the mean. So one of the ways we could have climate change is if the mean temperature shifts. So for instance, if it shifted here to the right, we have a higher mean temperature, but the variability stays the same. The other way we could have this is that there's a change in variance. So while the mean might stay the same, we might get more extreme cold events in this middle figure here, or more extreme hot events. And then in the bottom figure is, you could sometimes have both. And I think that's what we're actually seeing, that our mean has shifted. So our temperatures are warmer, but we're also seeing more extremes. And I'm going to come back to this in a little bit, but we're seeing a change in both the mean and the variance. Now, let me talk a little bit about our greenhouse effect. So we have a natural greenhouse effect that is caused by certain gases like carbon dioxide in our atmosphere. It traps in energy and keeps our planet at a livable temperature. What we're really worried about is an increased greenhouse effect as we add carbon dioxide and methane and other what we call greenhouse gases that trap in energy and lead to a warmer Earth. And we know that these gases like carbon dioxide have been increasing over time. When I looked at this last May, it was at 419 parts per million. And this figure shows where it's been over the last several 100,000 years. We're at a higher CO2 level than we've been in hundreds of thousands of years. So we're in almost unprecedented territory. Now, these observed changes, as you would expect, by trapping more energy, we're seeing higher temperatures. And you can see this is global surface temperatures. And you can see, especially since the mid 20th century, we've been seeing these rising temperatures. 2020 was the second warmest on record. It was about 2 degrees warmer than the pre-industrial period. The 10 warmest years on record have occurred since 2005. So we're breaking a lot of records. It is getting warmer. We have computer models that predict what changes might look like in the 21st century. We don't know exactly because this depends in part on our own behavior, whether we control greenhouse gas emissions or not, how effectively. But these models by the 2100 estimate that the global average temperature could go up between 4 and 10 degrees Fahrenheit. Now, I've got another figure. A lot of people look at this, and this is where the weather and climate comes into play. Like 4 degrees doesn't seem like a big deal. But let me show you this figure here to place in perspective when we look at it from a climate perspective. So this figure goes back 20,000 years when we had the end of our last ice age. So our last ice age was about 7 to 9 degrees cooler than today. Okay, so this is climate. When the Vikings settled Greenland during the medieval warm period, so Greenland became a little bit warmer, they were able to settle it. It's about approximately 1 degree warmer than normal. And when the little ice age hit Europe, glaciers expanded, it got colder, it was about 1 degree cooler. So these small changes could make really big differences in terms of our climate. I should also mention that, when we go between these glacial periods and what we call interglacial or warmer periods, it takes thousands of years for the temperatures to change. But we're seeing an extremely rapid rise of temperature, in the 20th and 21st centuries that is occurring at an alarming rate. Now, I mentioned that our mean temperatures are going up. And one of the other things with climate change is you get a change in the variability. And we're seeing more extreme events occurring. The one that, and this figure kind of shows on an axis here, we have our strongest evidence, and then we have areas where we only have limited evidence. So our strongest evidence is we know we're going to get more heat waves. And I'm going to show you another figure that will highlight that. We're seeing more coastal flooding because sea level rise. We're seeing more extreme precipitation events. An example, in Europe, they had that massive flooding. No single event, we can say was caused by climate change, but it fits the pattern that we're seeing. More severe droughts. The Western US is experiencing a terrible drought. Some of the reservoirs are at their lowest levels in many, many years. So with heat waves, and since that's the focus of my talk, we're seeing longer heat waves. They last longer, they're more intense, they're hotter, they're occurring more frequently. And these are things that we saw this summer, these heat waves. The summer of 2021 has seen some incredible things. If you looked back in June, the Western United States had record-breaking temperatures. Arizona had high temperatures over 115 degrees for 6 consecutive days. The Pacific Northwest had a massive heat wave. And this was just a figure, these kind of gray dots kind of show the normal variability in the climate in the Portland area. And these 3 dots up here were 3 extremely hot days over triple-digit temperatures there. So extremely abnormal. Now, let me draw this stuff then to tie it into athletes. When we think about heat and health, a lot of people will immediately think about older adults who are higher risk, or people that have underlying health problems are more vulnerable. They don't immediately think about athletes, but athletes, and I should also add people that are outdoor workers, are also vulnerable to heat-related illnesses. They're often outdoors if you're participating in outdoor sports. Some athletes wear equipment like football players or lacrosse players, and they have a high level of exertion. Now, this all matters because among athletes, heat's among the top 3 leading killers, or causes sudden death in sports. Since 1960, 152 football players have died from heat stroke. Thousands of athletes suffer exertional heat illnesses each year. And let me link this up, just things that we saw this summer. I mentioned about these record-breaking temperatures that hit the Pacific Northwest. Well, these record-breaking temperatures, triple-digit temperatures in areas that normally have pretty mild conditions, occurred during the Olympic trials. Portland set high records, Seattle comes close. They had to suspend some of the Olympic track and field trials because of the extreme heat. This one showed 103. I saw numbers that were even higher than that during the trials. A heptathlete suffered some form of heat illness and had to be taken off the field and treated. So this had direct impacts on these athletes. Now, we can't control the weather, but there's a lot of things that we can do to make playing or participating in sports safer for athletes. And I like to think of it as sort of these three pillars. Activity modification, where you adjust the amount of work versus rest, the intensity of practices, how long they are, do you wear equipment or not? And a lot of these are driven by environmental monitoring. And given my background in climatology, I'm going to focus mostly on this part in the talk today. But the other parts are having an emergency action plan. So what do you do if there's a crisis? What do you do if a player suffers heat stroke? Do you have a cold water, I can talk here today, a cold water immersion tub, right? That's the gold standard treatment for athletes. Is there an AED available? Acclimatization is that physiological adaptation to heat. Does the policy have a period where the athletes can adjust to the heat, which, as I'll show you in a little bit, can greatly lower the rate of heat illnesses? So let me talk a little bit about environmental monitoring. This really is using weather data to understand how stressful the conditions are outside. So typically you will gather data on temperature and the humidity outside, the wind speed, the cloudiness or the amount of sunlight. Commonly in sports, or when we're trying to think about heat stress, we'll use what are called derived indices, where they blend multiple weather variables to give you an assessment of the heat stress. The heat index is one that's commonly used, and I'll talk about that in the next slide. The WBGT, or the wet bulb globe temperature, is less familiar to a lot of people, but is used a lot in sports, in occupational, and even the military settings. And I'll talk about this. And then there's the wind chill, which is used for cold weather conditions. And it blends temperature and wind speed. And I'm not going to talk about that today. So let me first start with the heat index. This is a derived variable. It combines air temperature and relative humidity. And it's probably the one that's most familiar to people. The National Weather Service uses it in their heat watches and warnings. And the way it works is that on the top axis here, you have your air temperature. So let's say it's a 90-degree day. And then on the vertical axis here, you have the relative humidity. So at a temperature of 90 degrees, as the relative humidity goes up, it's going to feel hotter outside because that humidity makes it hotter for sweat to evaporate, and it short circuits your body's air conditioning system. Now, this can be useful because it does show the role that humidity can play on heat stress, but it makes a lot of assumptions that people aren't often aware of that make it not as useful for people that are outdoors participating in things like sports. It assumes that you're in the shade. If you're in the sun, that can increase your heat stress. The National Weather Service mentions it could be up to 15 degrees hotter than what the heat index says if you're out in the sun. It assumes low or moderate activity. So if you're participating in rigorous conditioning activities, your metabolic production is going to be a lot higher, and your heat stress is going to be greater. It also assumes you're not wearing equipment. So if you're a football player in full pads, that's going to make it harder for you to cool yourself off, and that's not accounted for in this index. So some caution needs to be used when you do use this index. Now, the one that is used a lot in sports, I know in Georgia, the high schools all have to record the wet bulb globe temperature. This is a measure that was originally developed by the military back in the 50s to protect their recruits from heat stress. And what it tries to combine are three different things that can influence heat stress. So it's a weighted average of three different types of temperature measurements. It measures what's called the globe temperature, and this is just a black globe that sits on top of the thermometer, and it's supposed to mimic or give you a sense of the solar heating, how much the sun can heat you up. The second one I have labeled as WB here is the wet bulb temperature. And what it is, it's a thermometer with a wetted wick on top of it, and the water evaporates from it, and it's supposed to mimic evaporative cooling. So how well can your body evaporate sweat and cool you off? And the third one is called the dry bulb temperature, and that's just a regular air temperature. So this is the formula for weighting it. So the idea is it accounts for sun and indirectly wind, humidity, and air temperature, all the different factors that can influence heat stress. And as I mentioned, it's very commonly used in athletics, occupational safety, and by the military. The sensors can vary a lot in cost. The most expensive ones, this one is a Quest sensor, can be several $1,000s. You can get mid-price ones. This one is by Kestrel. It's about $500 or so. And then you can get less expensive ones that might be about $100. Now, one thing I just want to mention too is that with the wet bulb globe temperature, the values will often be lower than the air temperature, which can be confusing for people. A 90 wet bulb globe temperature is really brutal outside. But when we talk to coaches in Georgia, 90 is a pretty typical day. So you have to think of it as separate scales. And one of the ways to interpret how these measurements work is by using activity modification guidelines. This is one that's very commonly used by the American College of Sports Medicine. They have the WBGT reading here. So for instance, between 82 and 86, if you're doing continuous activity like running a marathon, those conditions become so dangerous, they would recommend that you cancel it. For non-continuous activity like say football or soccer, they have a separate set of guidelines, and they break those up for non-acclimatized or unfit or high-risk individuals, and ones that are acclimatized, fit, and lower risk. So for instance, if the wet bulb globe temperature is between 86 and 90, for a non-acclimatized or unfit person, you might want to stop the activity. But for someone who is fit, you might allow them to participate in the activity, but limit the intensity of the exercise and the total length of the training. Now, I want to share a little bit about the evidence-based policy that we developed in Georgia. So what precipitated this was we had 2 Georgia high school players die from heat stroke. And this alarmed everyone. And the Georgia High School Association contacted some colleagues of mine at the University of Georgia to conduct a study. And the study did a 3-year study to develop the guidelines. And then we had a follow-up 3 years where we assessed how effective these guidelines were. We had approximately 28 schools across the state. And you can see on the map here, we're representing the different regions of Georgia. We collected EHI, or exertional heat illness data, from thousands of athlete exposures. And we used the data from the first 3 years to develop a heat and humidity policy. And I should just mention briefly, there's several different types of exertional heat illnesses. The least serious is the muscle cramps, very painful, but not life-threatening. There's heat syncope, heat exhaustion, and then exertional heat stroke, which is the life-threatening one. We didn't have any exertional heat strokes in our study, and we focused on the heat syncopes and heat exhaustion in developing our policy. Now, let me show you 2 figures that are probably the most relevant to our guidelines. So this was the first part of our study done between 2008 and 2011. And the red line is the heat syncope and heat exhaustions, and the gold line there are the total, which included the heat cramps. And what you can see is that in week 1, the number of injuries is very high the first few days. This is the kind of highest risk period where players aren't likely to be acclimatized, they're less fit. And then by day 4 and 5, it dropped off considerably as the players became more acclimatized. This went into our policy, knowing, in that we required an acclimatization period. The second piece of information that we have was we looked at the heat injuries by wet bulb globe temperature. And you can see around 82, it was pretty low, and it began to go up. And in the 86 to 90 category, it went up considerably. What was interesting is that in week 1, you can see the rates at this level were much higher than in subsequent weeks because the players became acclimatized. So we saw with increasing heat, there was increasing injury rates. We also saw that when it went over 90, the conditions dropped, which seemed odd to us. When we talked to some of the trainers, it turned out that it was just really hot outside, and a lot of them pulled their players in or limited the practice. So they recognized it was dangerous outside and limited the practice. And as a result, the injury rates went down. So based on some of this information, my colleagues met with the coaches and the Georgia High School Association, and they worked out a new evidence-based policy. So based on the injury rates and how they changed over time, they required a 5-day acclimatization period. They required on-site wet bulb globe temperature measurements. So every high school in the state has to purchase a sensor and monitor on-site. And the players had to follow activity modification guidelines. So as it became increasingly hotter, you would have to make adjustments to the length and intensity, the number of rest breaks that are needed would be altered. And here's an example of the activity modification policy. It looks somewhat similar to the American Academy of Sports Medicine guidelines, but as an example, under 82, we didn't see a lot of heat injuries. So we had normal activity, but with a certain number of rest breaks. And as it got hotter, so for instance, between 87 and 89.9, practice time is limited to 2 hours. Players were restricted to helmets, shoulder pads, and shorts. Other protective equipment needed to be removed and provide more rest breaks with a minimum rest break of 4 minutes each. And as it got even hotter over 92, they'd have to cancel the activities. Now, we then did a 3-year follow-up study to see, did these policies really work? And again, we focused on the heat syncopes and heat exhaustions. And the black bar is the pre-period, and the red bar is our post-period. And you can see when we control for the wet bulb globe temperature in every category, we had decreases in the heat syncope and heat exhaustion rates of 35 to 100%. So we saw that as extremely successful. Until this summer, where it's possible there was a player who died from heat stroke, we haven't had a single death when people have been following our policy. So it's been very successful in protecting our high school athletes. Now, I want to talk a little bit about weather climatology and forecasts and how we can use that information for pre-planning to make things safer for athletes. And this was actually a forecast for Kashima in August 2nd. I think this is one of the locations that our women's national soccer team competed in. And you can see that in Japan, it's been very hot and especially humid and very difficult for the athletes. So my colleague at Arizona State, Jennifer Vanos, did a study where she compared what this Olympic might look like using climatological data from past Olympics. And one of the things that we noticed was that this is going to be one of the hottest Olympics on record. And this was before using climate data. As expected, this has been an extremely hot and humid, and probably the hottest one I've seen, on CNN, heat humidity make Tokyo the worst in the history of the Olympics. I've seen, there were quotes from professional tennis players saying that they played for 20 years, and this is the hottest conditions he's played in his life. One of the other things that has been a difficult thing for the athletes is that because of COVID-19 restrictions, many of them have had less time in Japan to acclimatize to the conditions. They only arrived in the Olympic Village a few days beforehand. So this has also made things difficult. Now, the IOC was aware of this, and they developed multiple heat countermeasures. One of them was educating athletes about the importance of practicing good heat safety, acclimatizing, hydration, and so forth. They developed a set of pre-hospital management policies for exertional heat stroke that included cold water immersion. So all of the medical teams were using the same evidence-based policy. And they did things like moving the marathon from Tokyo, which is really hot and humid, up to Sapporo, which is much cooler. And the marathon is one of the more dangerous activities because of its duration for heat stroke. So there's several countermeasures they took. I've seen other things that organizations have used, like FIFA rescheduled the World Cup. Qatar is very hot in the summer when they normally have this. They rescheduled it until later in the fall when it was cooler. When they had one of the big competitions in Doha, Qatar in 2019, they scheduled the marathon at midnight. I don't think the athletes were really happy about that, but it made for much safer conditions for them to compete. Now, let me wrap up here talking a little bit about climate change and this idea of vulnerability. How do we plan or anticipate developing new policies as we move forward? And one of the things I found really interesting was there's a field called sports ecology where they link sports and the natural environment. And there's a paper by Orr and Inouye which proposed something called a climate vulnerability to sports organizations, or a CVSO framework. And I'm going to show you some work that we did where we borrowed this idea. And it combines the idea about climate impacts to organizations. So for instance, what I just talked about with heat in Tokyo is one impact. It could be extreme precipitation. It could be in the Winter Olympics, lack of snow. And then it also combines with organizational climate capacity. So the adaptive capacity of an organization to handle these changes. And one of the things I like about this framework is that there's a lot that we can do to modulate or adjust the vulnerability we have to different activities. And let me kind of walk you through this. So this framework, in our case, we looked at the hazard. So we looked at wet bulb globe temperature and we looked at maximum summer values. And on the bottom axis, we looked at a heat safety policy. And I'm going to show you where we got that from in the next slide. And then it breaks, and we did this by state policy, into 4 quadrants. What we call the fortified quadrant, which is places that are well prepared for the hazards they're facing. The problem quadrant are ones that have insufficient abilities to handle the hazards they're facing. The responsive quadrant are locations that are responding to their current conditions. So areas with cooler climate are probably responding with less heat policies because they don't see it as much of a threat. And then the last one is the proactive quadrant, where locations with cooler climates, but they have good policies and they're prepared for it. So let me explain a little bit about this heat policy. The Korey Stringer Institute, or KSI, is located at the University of Connecticut, and they're a really fantastic resource. They developed a sport safety policy evaluation, and they ranked all the states. Heat is one of them, but they have a whole bunch of other safety guidelines included in there. And you can see New Jersey's number 1, Virginia's number 24th. And what they did was, for heat, they tied in the pillars that I'd mentioned before. So you got policy points for heat acclimatization, wet bulb globe temperature activity modification. Do you have a cold water immersion tub if there's an emergency? As an example, Virginia got points for heat acclimatization, but no points for wet bulb globe temperature monitoring or for requiring cold water immersion tubs. And this is kind of a series of questions that they include, and you get points for each of those. So we took this framework and we applied it to state high school associations and looked at their heat, again, based on sort of the worst conditions in the summer. And we broke them up as, the hotter locations and the cooler locations. And we gave them policy points based on the Korey Stringer Institute's policy guidelines. So there's a maximum of 18 possible points. And one of the things I should mention is, like, some states like California have very complex climates. along the coast, it's very mild. California also includes the hottest place on earth, Death Valley. So we averaged it over the whole state because state policies are usually based on this, but are aware of some of those limitations. So one of the things I wanted to point out with, states in this area, Georgia and North Carolina have really good policies and they're well prepared for things. Again, places like New Jersey and Massachusetts are also cooler climates, but well prepared. States in this quadrant, though, are hot and they have less policy. And you can see places like Texas and Oklahoma and Virginia are in this location. One of the things, though, I really like about this is it shows that the control that we have. Again, we can't really control the weather or really even directly the climate. But Louisiana was one of the hottest states and had almost no policy points. And they recently updated their policy and they jumped all the way into the fortified quadrant. So there's a lot that states can do to change their policy. And I know that the Korey Institute has worked a lot with states. They're going to visit every state to try to encourage them to update their policy, at least for high school athletics. And then you have schools down here on the bottom here, like California or Maine or Washington State, that generally are cooler climates. But as we saw, some of these extremes can happen. It can get extremely hot in Seattle. You have to be prepared for it. So I think this framework can be helpful in showing where we need to make immediate attention in this problem quadrant. Although with climate change, as things get warmer, more and more of these locations are going to get pushed into the problem quadrant, and we really need to be aware of this and vigilant. So let me just wrap things up here. So, I think you probably got my point here that we're facing a climate crisis. We're seeing longer, more intense heat waves, increased heat hazards for our athletes. But one of the other things I hope I came across is that there's a lot that we can do to protect the safety and health of the athletes. And the other thing is to be aware of is that, participating in sports is extremely important for, their health and being active and so forth. So we don't have to stop participating in sports because it's hot. We just have to be smart about it and develop good policies to protect them. So with that, hopefully I'm on schedule here. Thank you so much, and I'm happy to answer any questions.
Well, thank you so much, Dr. Grundstein. That was excellent. I learned so much, and it really gives us as clinicians an understanding of what we can do to protect our patients, our athletic patients, and keep them safe so they can remain active in sports. Before we go to questions, we did want to share a few programs, related programs that VCCA has developed. And we'll share a slide with you now. Our first is our Youth Athlete Heat Protection Program. And this is something that we're trying to get the word out that you've discussed here, Dr. Grundstein, about the vulnerability, particularly of middle schoolers who don't even really have a lot of programs in place to protect them in sports currently in Virginia. And I think you also highlighted that there remains a need to educate people on the risks of sports in Virginia overall. And so this is a brochure that VCCA developed, and it has been endorsed by the Virginia Department of Health. And we're very proud and happy to be able to offer this for free. It's a beautiful trifold brochure that can be used in offices or by athletic trainers or youth programs. It's in English and Spanish, and it can be ordered on our website. And you can order it to be delivered to your office. So please feel free to go to our website here and place your order. And again, they're free and they're in English and Spanish. It also comes as a poster. And you could advance the slide, please. And the next one I wanted to tell you all about is you're probably all aware that there is a lot of action right now on the national level in terms of climate solution policy. And we maybe have a generational opportunity right now to enact climate solution policy by Congress. And VCCA wants to ensure that our clinician voice is heard in supporting climate solutions to protect the health of our patients. So we developed a 1-minute video that's linked to an action, which I want to share with you all now. Well, we can't hear any sound.
Overcoming challenges is what we're trained to do in medicine. Implementing climate change solutions will protect our patients now and in the future.
More air pollution worsens asthma. This particularly harms communities of color. That's why I support public transit that helps clean the air and protects my patients' lungs.
Building walkways and bike lanes helps people stay active and healthy while protecting our climate.
Heat waves are dangerous for people on some medications. That's why pharmacy students like me support clean energy solutions that help stop global warming.
Hotter summers make it harder for kids to stay active and safe. Increasing community green space and shade helps my patients play safely outside.
Urge your elected officials to support climate solutions. Together we can build a cleaner, safer, healthier future. We're ready. Let's do this.
Excellent. So now that you've seen this inspiring video, you can go, we're going to take 90 seconds, and I'm going to put this on my timer for you all to go to our website. I think we put it in the chat. Jayla will put it in the chat. Let's see, we'll add it in here now. So you can go to our website, virginiaclinicians.org, call to action, and take this action right now to reach out to your congressperson. So I'm going to press, we're going to do 90 seconds, and you can just go online, virginiaclinicians.org, and to our call to action. Ready, set, go. And all you have to do is put in your name and state. And there it is in the chat if you need it. We have about 30 more seconds. Ten more seconds. All right, well, I'll stop it there. And you can please, you can continue. That's right, it does identify writers as Virginians. That is true. I'm not actually sure what we should do about that. There is at the Medical Society Consortium, they have a national action that you can take. So maybe this is going to be less appropriate for those of you on the call from North Carolina and Georgia. So that is correct. All right, so we are now going to go to some questions for Dr. Grundstein. And please feel free to put your questions in the Q&A or in the chat, but Q&A is probably best. Well, as we wait for some questions to come in, Dr. Grundstein, I'd be curious to know, to hear from you about is there a difference in risk of athletes in northern versus southern climates as a result of lack of acclimatization?
One of the things that we found was really interesting is when we looked at heat stroke deaths of football players across the country, what was more important is how unusual it was to their local conditions. So, people in say Georgia are really used to the heat, but people up in, Massachusetts or, some of the more northern areas, when they did suffer a heat stroke, it was really unusual by their local standards. So that's why it's really important to look at the climatology and consider what's hot for that location, because that's what they've acclimatized to.
So a given temperature could be more dangerous in Washington than it is in Arizona or something like that.
Exactly. And that's why we did some work where we actually created heat safety zones with different thresholds before you have to change your activity. So the thresholds would be lower in a cooler area than they would be in, say, the southern part of the country.
We have a couple of questions coming in.
Okay.
Oh, here's a from Patricia Flores. And how does climate change affect asthmatic athletes?
Okay, so this is where I click answer live.
Yes.
Okay, good. All right. All right, thanks. So this is not something I'm an expert on. One of the things that though I do know is, the extreme heat out west and the more fires have reduced air quality. One of the other things that I work on is called thunderstorm asthma. And as our pollen season gets longer, thunderstorms, and this is a whole other topic for another day maybe, thunderstorms can actually set off an asthma attack in people. So at least those are the two things I could think of, but this is definitely not my background, so I don't know if I can give you the best answer here.
Well, I think that that's actually very relevant, what you mentioned in terms of air quality and affecting athletes in terms of pollen and wildfire smoke. Next is from Evan Brockman. How often, at what points during
wrong one. Sorry, wrong one. Oh, there we go. Okay.
I can read it here. How often and at what points during practice do you monitor the wet bulb globe temperature? I'm a pediatrician in Georgia, and this seems to confuse coaches, especially in after-school programs.
Yeah, no, that's a great question. One of the problems, I think, at the high school level, or when you get to the college or pro levels, they can afford these instruments and they have staff that can do this. For after school programs, it's usually someone's parent or someone volunteering to help, and they may not even be able to afford a wet bulb globe temperature sensor. But if they do have one, at least at the high school level, we recommend that they take the measurements about a half hour before the practice to kind of make a determination about what they should be doing. And then, at least every half hour or hour into the practice, as much as feasible, to make adjustments as needed.
Excellent. We have one here from Dr. Kitchen. Could you describe the steps taken and any problems with getting all school athletic associations across the state to adopt these policies to protect their athletes? And I think that's very relevant to Virginia, because as I understand it, actually these policies are developed by school boards and counties rather than the state.
Yeah, and that really is going to depend. In Georgia, it was the Georgia High School Association. So that was the organization we worked with to set the policy. In Texas, for instance, where there's been a push to adopt wet bulb globe temperature and other heat policy standards, it has to go through the state legislature. So that's a whole different kind of animal. And you'd mentioned in Virginia, it's really depends on the school district. So I think it gets much more complicated when either you have to go to the state legislature or you have to go to multiple school boards. At least in Georgia, it was much easier. We could go to that one high school association to implement it across the state. But one thing I will say is I know they got this in Louisiana, and I'm not sure how they, whether it was through a high school association or through the legislature, but it took a lot of really dedicated people that worked really hard to kind of promote this and push for those changes. And I think, there are groups out there like the Korey Stringer Institute that can really be helpful allies in kind of educating people and kind of promoting the adoption of these policies.
Excellent. So we have one from Evan Brockman. Oh, just that she was very glad to hear that you're looking into thunderstorm asthma, which is a concern in Georgia, where Dr. Brockman practices. And next, from Michael Ikniowski, are there specific exercises or guidelines for acclimatizing to exercising in heat and humidity?
I would probably defer to my colleagues who are in the athletic training profession or physiologists in terms of the best way to do that. I think, at Georgia, our policy is you basically start slow, right? Don't have these really long, intense practices. Don't let them wear pads. If that sport includes pads like football, but kind of bring them gradually into it with increasing intensity. After, usually I've seen in Georgia, we use 5 days because that's what our data suggested. Other literature I've seen is 10 to 14 days to fully acclimatize. But I think the big thing is getting exposed to heat, but not overdoing it as you kind of work up your acclimatization.
One thing I'd be interested to hear your thoughts on is the physiologic mechanisms of acclimatization, because as I understand, the risks of heat illness, the variable risks, some of them are not that vary with acclimatization. Some of them are much less intuitive than heat illness. For example, there was a study on congenital heart disease in newborns as the potential rise associated with elevated temperature, heat exposure in pregnancy, and even that seemed to be affected by latitude and acclimatization of the effect of the mothers. Mm-hmm. And so I thought it seems that this is a fairly complex, acclimatization is a real complex physiological process that's not just getting used to exercising in the heat.
No, I agree. This is a very complex process.
No, and I was just curious. I don't know much about that myself, that those processes that occur.
And yeah, I'm getting, as a climate scientist, I'm getting a little outside of my expertise in that area. But you're right, there's a lot of different physiological processes that are going on here as you adapt. Most of the work that I've seen has been tied to athletes and how you prepare them. But you're right, just with other people as well, that role of what you're used to and how you're adapted can be complex and obviously important for people's health.
All right. And let me see. I think that we went through all those questions. And there's a question from Dr. Y. Is there a routine measure of regional surface ozone level, and how does that play into the discussion?
I know that some of the air resource boards. I know, like in Georgia, there's websites where you can get an air quality index, an AQI, where that includes ozone, and that can at least provide you a guideline or a baseline for what the air quality levels are in your location. And I believe this, I think it's through the EPA, you can look at it in almost any state to get that information.
Excellent. Yeah, that's some very important, relevant information for those of us in practice.
Yeah, that's at the EPA Air Now. That's it.
Excellent. And I have one more just little question. In terms of the actual physical machine, the wet bulb globe temperature monitor, how does it measure wind speed?
It doesn't if I can talk here, it doesn't directly measure wind speed, but it gets indirectly brought into it. The higher the wind speed, it removes heat from the globe, so it affects the globe temperature. And it also can increase evaporation from the wet bulb temperature. Just like, when it's windy, it could evaporate sweat from your skin and make you feel more comfortable. It can increase evaporation from that wet bulb and lower that as well. So it doesn't directly measure, but it's sort of baked into the computation.
I see. Thank you. All right. Well, thank you so much, Dr. Grundstein, for your time and sharing your expertise, and really grateful for your research and informing us all as practicing clinicians about the risk of heat illness for our athletes. And with that, I think we'll pass it on to Jayla again, just to speak to give some information about CME credit. Thank you again.
Yes. Hi. Thank you so much, Dr. Grundstein, for that amazing presentation. I do just want to make sure that you guys all remember, you'll get a link tomorrow in your email with the steps you can take to get your CME credits. Let me go ahead and show you guys this. If you'd like, you can also use the QR code here, and you can get the step-by-step instructions immediately. So I'll leave it up for a minute if you guys would like, and then you'll get that email tomorrow. And oh, thank you so much for reminding me, Julie. So the presentation today will be available on our website. It'll go live tomorrow as well.
And I do just want to give a final shout out to our partners for this presentation, Georgia Clinicians for Climate Action and North Carolina Clinicians for Climate Action. I think these are great opportunities for us all to work together because these really are regional challenges that we're facing. And it's makes a lot of sense for us to be learning together about these challenges that we face together. So thank you all. Bye-bye.
Yes, thank you, everybody. Take care.
Bye. Thank you, everyone.